and welcome back to the next jumpstart in our series, Microsoft Virtualization for VMware Professionals. I'm Simon Perryman. I'm joined by Matt McSpirit. We both work for Microsoft, and we are both VMware certified professionals. So in this module, we're going to be talking about storage capabilities, specifically focused on our core Windows Server platform. Now, before I turn it over to Matt, we got one interesting question that came in from the last module. And the question is basically, hey, we think the Hyper-V server is cool. There's a lot of great features. But how exactly does that compare to the core iSCSI platform?
Yep. So it's good that people are already seeing that Hyper-V has got great features, you know, the Hyper-V server, even though we've only just scratched the surface. But fundamentally, Hyper-V server is all about virtualizing VMs. It's not about providing any other capability. If you think about iSCSI as the hypervisor, if you were to download the free version, all its job is virtualizing VMs, fundamentally. Architecturally, Hyper-V server and iSCSI are different. One's a microkernelized hypervisor architecture, the other one is monolithic. But ultimately, their sole job is virtualizing machines and running them efficiently and abstracting the physical hardware through to the virtual machine. The differences between iSCSI as a free hypervisor and Hyper-V server as a free hypervisor is just the sheer number of features. Hyper-V server has a massive amount of features. All that we're going to talk about today is in Hyper-V server. It's enhanced with System Center, but you don't need System Center exclusively to take advantage of some of the features like clustering, live migration, some of the other stuff we'll talk about as well. I can still do that with pure free Hyper-V server and the remote server admin tools that we had addressed before. With VMware, however, unless I'm using that iSCSI hypervisor in conjunction with vSphere and vCenter, so I've bought something, then I'm going to lack some of the HA features, VMware HA, fault tolerance, vMotion. I need a SKU of vSphere, be it Essentials Plus, Standard, Enterprise, or Enterprise Plus Edition, whichever one is most appropriate for your organization. I'm going to need to buy one of those to unlock some of the advanced capabilities. So hopefully that gives a little bit of contrast. It's all about just running VMs, but one is very featured and is enhanced with our management tools, but it's not compulsory. One is got a certain amount of features, but you need the management tools too.
And I think it's important to add, beyond just having a broader feature set, the scale is
as we've seen, that's all we've looked at so far. Yeah.
So the 1,000 virtual machines per host, 8,000 virtual machines per cluster, you still get that with the basic free Hyper-V Server Edition as well.
Yeah. I mean, you'd probably think if you're running 8,000 VMs, you may want to use System Center for
advanced management.
It might be the way you go. You know, we're not forcing you, but you know, I'd say it's probably a good idea to test that, and we'll see that later in the afternoon. Not an 8,000 VM cluster, but yeah, that's the kind of thing. If you're starting to manage at scale, because you're running 64 hosts, you'd probably want to go to System Center for that.
Great. Well, let's jump into this module here and talk about some of our storage capabilities.
Yep, so we're going to look at storage, and we're also going to look at resource management. Resource management being how we manage memory, how we can measure resources, how we can provide a consistent level of service for certain virtual machines as well. So let's dive in. Storage, resource management. So what I want to look at first is some of these storage capabilities that are new within Windows Server 2012 and Hyper-V Server. But I also compare and contrast just what options we have on both sides of the table. Now, what I'm getting at here in this first bullet under Microsoft and VMware are the choices you've got around providing storage for your virtual machines. Now, there's one that's missing on there, which is local storage. I can obviously just use DAS storage on there if I want, be it SAS, SATA disks, SSD if you're really fancy, Flash if you've got it, that's up to you. But ultimately, if you're looking to build things like clusters, which Simon will do a great demo of that later on in the morning, clustering requires some form of shared storage on both Microsoft and VMware. Be it iSCSI, Fibre Channel. With Microsoft new in 2012, we've introduced support for SMB3 storage. So literally being able to place VMs on / Simon's file share. It makes it really easy to manage. People who are familiar with administering file shares, great stuff. And it's evolved and enhanced in terms of how we manage that as well. With VMware, iSCSI, Fibre Channel, NAS, NFS type approach as well if you want to use those. What's interesting is Windows Server 2012, and this might be something you know more about as well, you can use that as a platform for VMware. we've got a capability within Windows Server 2012 to transform it into a storage repository for VMware, things like NFS and stuff. So yeah, we've got a solution that can work in conjunction. But when we think about VM disks specifically, so on VMware, when you're creating a VM, you're creating a VMDK file. Typically, not always, sometimes you'll create a raw LUN through to the virtual machine, known as a raw device map, of which there are a couple of different types. With Microsoft, a raw LUN presented from SAN through to VM is known as a pass-through disk. So in terms of terminology, and actually at the end of the slide deck for the morning, there is a V glossary, we've called it, which will help you translate some of these things, VMDK to VHD and so on. So on the Microsoft side, a virtual disk, the acronym is VHD. Virtual hard disk. But in 2012, as we'll find out shortly, we've enhanced this and we've renamed or we've added a new type of virtual hard disk known as the VHD-X file. I don't know do you know what the X stands for?
Extra awesome. I don't know.
Extra awesome.
There you go.
Making up words as well. All one word, I assume. So VMDKs on VMware, VHDs and VHDXs on Microsoft. What do we think, what are the different types within that? Because VHD is a term that we give to, it could mean multiple things. When we think about how we provision these virtual disks, we'll first focus on the Microsoft side. I can thin provision a virtual disk. What does that mean? Well, I can create a virtual disk for a virtual machine that's thin provisioned, but I say it's got a maximum size of 80 gigabytes, which means the virtual machine inside the guest OS will see 80 gig. You'll think, great, I've got 80 gig to play with, I can store my files and stuff. But the size of that thin provisioned VHD actually on the physical storage, so in the physical world, may only be 10 gigabytes, depending on if you've just installed an OS and a couple of applications. So thin provisioned, you're only consuming on the storage, on the physical storage, what the VM is using inside. A fixed disk takes a little bit longer to create because what you're saying now is, okay, I want an 80 gig fixed size virtual disk, VHD or VHDX file. And with the 80 gig fixed size VHD, we're zeroing out all of that virtual disk up front to ensure that it's secure and we know exactly what that size of that virtual disk is in the physical world and inside the virtual machine. So fixed is slightly different from thin, and you'll see a performance delta associated with that. Differencing, however, is almost like this parent-child relationship. So I can create a master disk and then I can create sub-disks off that. So if you imagine I created a sysprept, or VDI is a good example here. With VDI, I could create a gold master image virtual disk, mark it as read-only, and then I could create differencing disks off this to represent all of my individual virtual machines. So those differencing disks are where the writes go from those virtual machines, but the read-only master disk is where all of the core OS stuff comes from. So differencing, thin, and fixed. And VMware have a couple of different options. Thin provisioned, very similar. But when it comes to thick provisioned, so fixed in the Microsoft world, you've got two choices. Either you can thick provision and not zero out at start point, or you can zero out at start point. So you've got two different choices, slightly more granular there.
Yeah, a lot of people actually ask me, where can you go do that in disk management? And so when you actually go and add a disk in disk management using Windows Server, you have that option for the quick format or not. If you do a quick format, you're actually not zeroing out all of the bits on the disk. If you do not do a quick format, you'll notice it takes significantly longer. We're actually going ahead and we're zeroing out all of the bytes throughout the disk then. So when you're doing your eager zeros, you zero out all of the disks. Same thing if you do not perform a quick format using disk management.
And finally, to provide that differencing equivalent on the VMware side, so those differencing disks on the Microsoft side, VMware linked clones is a good example, often used with VMware View, which is a VDI technology. So linked clones, again, that master image and lots of linked clones coming off that master image. So similar capabilities, similar ways. They're both just a different format and a different approach, but ultimately they're achieving the same goal. So just get us on a level set. But we've done a load in Windows Server 2012 and Hyper-V Server 2012 to enhance storage and integration across the board for Hyper-V and for key workloads. So think about Fibre Channel. Now, if you're an SMB, a small or mid-market, and you've made the decision to go down the route of iSCSI storage or network-based storage, then Fibre Channel probably isn't going to be top of your list. But maybe you've already got an investment in Fibre Channel storage, in which case okay, that's great, we can use it for storing VMs, but what if we've got a VM that we've got running on a Hyper-V host that's a really important storage-related workload and needs a more direct connection to the SAN for whatever reason, performance, maybe flexibility, guest clustering, as Symon will talk about later. Virtual Fibre Channel, new in Hyper-V, is going to give us that capability. And I wanted to show you a quick demonstration of just what's that all about. So we'll duck into my demo environment.
While Matt switches over, I just want to clarify one term he referred to there, guest clustering. Now, traditional clustering, this is where you connect your physical servers, your infrastructure servers, and you have virtual machines that move around or automatically restart and fail over from the physical host. Guest clustering is when we install Windows Server inside the virtual machines themselves and connect those virtual machines. So you have applications inside your VM, such as a SQL database, and that application can move around, that application can fail over. And now with our virtualized fiber channels, these virtualized HBAs, we're allowed to connect our SQL database through our host to fiber channel storage. So new enhancement giving you a lot more capabilities, faster storage and performance with guest clustering.
Yep. So what we've got on the screen here is Hyper-V Manager. So we're back in the same environment. And I've got a couple of hosts here. These are all running Hyper-V Server 2012. So node 2, 3, and 4. They're actually configured in a cluster, and we'll see that in a minute or two. But you'll see here, if I go into the settings for this particular Hyper-V server in the Virtual SAN Manager. Now, it's important to make sure that we're clear on terminology here. Some people in the industry refer to virtual SANs as like an appliance that can transform aggregated physical disk into some kind of highly available virtual SAN. And VMware have an offering in this space, the vStorage appliance. So that would transform physical disk and a couple of servers into a virtual SAN. That isn't the same as this here. So whilst it's called Virtual SAN Manager, it's just allowing me to manage the connection or the potential connection from my physical fiber channel HBAs through to my virtual fiber channel HBAs. So out of the box, step number one that I've got to perform here is I've got to, if this was completely vanilla or a new environment, I'd have to first create a new virtual fiber channel or a new fiber channel SAN. So I would click Create, I would give it a name. There we go, I'll name it in honor of Symon, and then I would tick these boxes here. These boxes represent the physical HBAs, so the host bus adapters that are physical cards that are connected to my physical SAN in the physical world, and I would tick them here. But I can't because they're already dedicated to Con vSAN that I made earlier. So we'll go over to that one. So imagine I've just made this, I've ticked the boxes. What this is doing is saying, okay, I can use these two worldwide, these two HBAs and connect them to virtual fiber channel. Just ticking these boxes at this point doesn't automatically connect VMs to them. It doesn't automatically create virtual fiber channel adapters inside the VM. It's literally just a, yes, you can use them. Now, if you've got lots of HBAs in a physical host, maybe you've got 4, and 2 of those HBAs are connected to a test SAN, and 2 of them are connected to a production SAN. That means that I may create a test vSAN and connect it to the first 2 HBAs that are connected to the physical test SAN, and I might create another virtual fiber channel SAN and call that production and tick the other 2 HBAs that were connected to my production SAN. So this means that inside a VM, I could connect it to those 2 different SANs. It's up to me how I do that. So I'm going to cancel out of there. Now, we'll talk about what kind of things you need on your HBAs to support that in a minute. But I want to pop over from there and have a look at Cluster Manager. And Cluster Manager, as the name suggests, manages our cluster. And we'll see how we get to this point a bit later on with a great demo from Symon at how we've built this cluster and how we've got to this point. But for now, we've got a cluster. It's got 3 physical nodes. And on there, they're all 3 nodes are configured for that vSAN that I showed you before, that con-vSAN. And one of the virtual machines, this particular con demo 06, if we look at the settings of this VM, you'll see that it's got 2 fiber channel adapters. Now I've chosen to give 2. I can add a maximum of 4, but I can't add it while it's running. So I can't add a virtual fiber channel adapter. I need to do it when it's switched off. And you'll see I've added these two while they've been switched off. I've chosen which vSAN that I want to connect them to. So remember, we used the example. Maybe one of the HBAs is connected to test SAN. Maybe one of them is connected to production if you want to carve it that way. In this case, I've just used both HBAs connected to the same vSAN. But what you'll notice about these ports for each of these two virtual fiber channel adapters is they have two sets of addresses. So normally a HBA would just have one. A physical HBA would just have one. Why do we give two? Well, that's to facilitate live migration, and we'll talk about that in a slide shortly. But let's look inside that particular virtual machine and see what it looks like on the inside. So we'll go to Device Manager. There we go. And inside the virtual machine, you'll see that I've got this HP, and it's HP storage that we're using in this case, multipath disk device. So I'm able to use MPIO, multipathing, not only on the host to enable me to have resiliency, performance, and those kind of things, but also inside the VM. So I've got that consistency between what I'm doing and how I'm configuring multipathing in the physical world to what I'm doing inside the VM. And you can even use in this case, I could use the HP multipathing specific software that they may provide me with my storage array. So again, I can use that in the physical world without restriction, and now in the virtual machine if I want to as well. And if I look at my volumes here that I've got here, you'll see here's this multipath, so this MPIO disk, fiber channel disk that's been exposed straight through from the fiber channel SAN, the physical fiber channel SAN, through to my virtual machine. And what you'll see is actually, if we go back, this disk, 46.3 gig free of 49. So it's a 50 gig disk, but it's got about 46 gig free. So 3 to 4 gigabytes used. But if we go into this VM, I've got 126 gigabytes worth of stuff in that volume. Okay, is this some magic virtual fiber channel stuff you're doing here? How can you have 126 gig of stuff on a drive that's only 50 gig and only be using 4 gig of space? What's going on? What magic is this? Well, I'm using one of the inbuilt tools within Windows Server 2012 known as deduplication. Remember, my hosts are Hyper-V Server. So this isn't a feature that's just restricted to Windows Server 2012. So let's have a look at what the kind of savings I'm making here. So if I go to Server Manager and I go to my volumes, and we can see my multipath I/O fiber channel disk, 50 gig in size, free space, my deduplication rate is 97%. Boom. That is big. That is a massive saving. I'm saving 123 gig. Now I'm hosting just virtual hard disks on there. Offline VHDs are just an example. And they're where you're going to see the greatest savings as you perhaps deduplicate file shares and My Documents folders for users. The savings would be less, but you're still going to see savings. It's a very granular deduplication. Not really necessarily related to Fibre Channel in any way, but I just wanted to show you that as an additional feature that's part of the core operating system. So virtual Fibre Channel, it's in the box. It enables me to pass through those Fibre Channel LUNs directly to the virtual machine and still have flexibility to do things like live migration as well, which we'll see later on. So I'll come out of the demo there. Fibre Channel, pretty cool stuff. I think you'll agree. So, a bit more about Fibre Channel. What's going on? We're connecting it directly to the SAN, as we said. Now, when it comes to live migration, and the reason we give two addresses, so worldwide name set A is flashing there. You saw that when we had the virtual Fibre Channel adapters inside the VM. What we're doing there is effectively saying, okay, while the VM is currently connected to the SAN and it's running on host 1, it'll be using address set A for that particular Fibre Channel adapter. Address set B is kind of ready and waiting. When we go ahead and want to live migrate that VM, we'll kick off the process, but the process will start to use worldwide node set B as part of that migration. So we'll get things going, we'll get things maintaining Fibre Channel connectivity, and then we'll effectively flick over control, and the virtual machine will now be running on the second host. So that second set of addresses gives us that flexibility. If we didn't have that, we wouldn't be able to live migrate effectively without losing connectivity. So as we've said, it supports live migration, 4 Fibre Channel adapters per VM. It needs NPIV, so Endport ID virtualization support. So if you're thinking, wow, that could be really useful, check with your HBAs and your SAN to see whether they support that. But it's giving that unmediated access to that storage area network, and it's giving us a more direct path for I/O, which is great for performance.
I actually have seen a few questions now come in talking about what are the different storage options that I have available to me for Hyper-V, and then if I want to extend it to a cluster. So we kind of covered the basic storage options for Hyper-V, including direct access storage.
Yeah.
But when we start to think about clustering, we need to introduce this concept of shared storage.
Yeah.
And the reason for this is we have to essentially put our VHD file or VHDX file, which contains the data about a virtual machine, in a location which all of our different servers that might be running this virtual machine can access. So if I have a cluster, I can either use a storage area network so that my nodes can simultaneously access it, or in Windows Server 2012 we support SMB3 protocol, which is basically communicating as if it's a file share. So long as all of my nodes can access this share over SMB, we can use this as actual storage. And so in addition to SMB 3.0, you can use serial attached SCSI, Fibre Channel over Ethernet, or iSCSI. So there's a lot of different deployment options that you have for configuring this type of interconnected storage, shared storage.
Yep, correct. So next area of storage, what do we want to talk about? Well, I want to talk briefly about the support for a new, but in many cases for some customers it's an emerging standard in disks. So 4K disks are effectively increased capacity, increased resiliency, and just overall better performance for disks. But they're not as prevalent yet. It's still early days. But we want to make sure that Hyper-V supports these from the word go. Because when you want to invest in your next storage platform, whether it be direct attached storage or SANs that may incorporate these larger capacity, more resilient 4K sector disks, then we want to take advantage of that. And the key thing to note is that Hyper-V is optimized to run on those disks. From an alignment perspective, from a performance, we're doing some clever stuff in software with Hyper-V to ensure that they perform optimally on this next generation of disks. So we're ensuring that things are aligned and we don't get into situations like that in the diagram there, where the actual blocks are misaligned, which can cause extra reads and writes here and there. So we can host virtual disks on native 4K disks, but there's also 512 emulation disks, which kind of have some of the benefits and features of 4K disks, but they're designed as almost like a stopgap between regular 512 disks and also the 4K disks. So we improve performance on those emulation 512E that you may see listed and you may have in your environment, but on native 4K disks, Hyper-V fully supports that. So that's good news and future-proofing you. VMware doesn't support those today. So that's an interesting, at the moment, how things are. But then we think about, okay, capacity. Capacity is one of the things we didn't call out actually in the scale table earlier on when we were comparing previous Hyper-V with current and also Hyper-V with vSphere. In Windows Server 2012, we have blown the doors off storage and capacity on a VM basis. We can now create virtual machines with virtual disks of up to 64 terabytes in size. Now, I don't have 64 terabytes in my environment, but I can still create 64 terabyte virtual disks. And I want to show you what that looks like briefly in a quick demonstration. So I'm going to go to my environment here. And 64 terabyte disks, you might say, okay, well, what's the current restriction? Well, the current restriction in Windows Server 2012 in Windows Server 2008 R2 was virtual disks of up to 2 terabytes. Plenty for most, but some organizations are looking for more. They're looking for greater capacity, and they don't want to do it by adding lots and lots of 2 terabyte disks and configuring software RAID and doing lots of stuff that way. They want it to be simpler and more effective and easier to manage. So I'm in my cluster manager interface again, and I'm going to select Demo 6. Demo 6 seems to get used for quite a lot of things, but in this case, it's all good. And I'm going to choose the SCSI controller. Now, the SCSI controller, if you're from the VMware side, you think, okay, do you not boot from SCSI controller in Hyper-V? Well, in Hyper-V, we boot from a virtual IDE controller. That's important to know. If you move across from the VMware side with your education and you think, okay, I'm going to create a VM with a SCSI controller and attach my boot disk to it, in Hyper-V, that's not going to boot. It needs to be attached to the IDE disk, so just a tip of the day, if you will. The SCSI controller, of which I can add up to 4 per virtual machine, and I can attach 60, 64, 65 disks to an individual SCSI controller. So that means I can attach around about 250 plus virtual disks to an individual VM. Pretty scalable. But one of the advantages of the SCSI controller, unlike the IDE, is when I click IDE, you'll see these are grayed out. Hard drive, DVD drive. I can't add them on the fly. I can't hot add. With SCSI, I can. There it is. I can click it. I can click add. Microsoft support within Windows Server 2012 Hyper-V and Hyper-V Server the ability to hot add storage. But we can also hot add memory, we'll talk about a bit later on. VMware can hot add other stuff, NICs, but also processors. The thing with processors is hot adding processors, you can't hot remove, so once it's in, it's in. With the virtual disks, I've got that flexibility. And VMware can also hot add disks as well. So if you're used to doing that in the VMware world, you've got that same flexibility here in the Microsoft world as well. But the CPU side of things, the guest OS has to support it. So not all guest OSs support a processor being hot added. You may see it in Device Manager, you may not. It may not get used until a reboot, which is less than hot. But it's still a useful capability and something that Hyper-V doesn't address today. But let's hot add a hard drive. And this will build actually on what we were talking about before when we were talking about the different disk types. Because you see I've added the hard drive here. This one's already got a couple of hard drives already attached. I'm going to go New. And I'm going to go through the new virtual hard disk wizard. We'll go next. Notice I've got a choice. Do I want to go down the VHD route, which is going to restrict me to 2 terabytes? Do I want to go down the VHDX support, VHDX format, which supports up to 64 terabytes, more resilient. We'll talk about that shortly and the way it uses a log to ensure consistency and enhance performance. But it's not supported in OSs earlier than Windows Server 2012. That doesn't mean the guest OS needs to be Windows Server 2012. It just means the host. VHDX is specific to Hyper-V in 2012. We'll go next. And here's those choices I talked about before. Dynamic, fixed, or differencing. Now, if I choose fixed, and I want to create a 64 terabyte virtual disk, I'm going to need 64 terabytes of physical storage to run this, to host this. I don't have that. I'm going to choose dynamic. And go next. We'll give it a name. So we'll call it, be careful with my spelling, Symon Disk. And I'll browse where I'm going to put this. I'm going to put it in the cluster storage volume, and let's drop it in volume 1 here. That's fine. And we'll go next. Now, create a blank hard disk. Do I want to copy the contents of a physical disk or a couple of different choices there? I'm going to use 536 gigabytes, which is 64 terabytes. We'll go next, and we'll go finish. And there we go. So it's created, or it's started to create it pretty much quick. And we'll go apply, and we'll go OK. And what I can see when I go inside this particular virtual machine now that we've added that particular virtual disk to it, and I go to, again, being careful, disk management, we should see that I've got the 3 that I had earlier, and there's this one here offline. So we'll bring this online, we'll initialize, and then we're good to go to start using that. So that's how, very quickly, I've created a 64 terabyte disk, but because it's dynamic, it's thin provision. So I'm not losing 64 terabytes of space on in this case, my small SAN. So dynamic disk, in the operating system, I'm seeing the full 65 terabytes that I could start to use, but in the physical world, it's probably only using a couple of 100 megabytes, so relatively small. And as I fill that up, as I add more stuff in there, then that's going to increase in capacity. So very quick, very simple demonstration. I'm going to pop back to the slides now, but hopefully that's giving you an idea of a little bit of virtual hard disk creation and how big they can go. But if we drill into that a little bit more, as I said, the capacity, 64 terabytes. Corruption protection against power failures because of this log that stores things temporarily before writing it to a different part of the disk. So that having that log ensures we have a better, not only alignment, so optimal structure, but ensures that we're protected in case there was writes waiting to be written to the main data region, but there was a power failure at that time. So we're helping protect against things like that. And the key benefits are massive capacity, protecting that important data, and quality performance on large sector disks, because the VHDX is aligned to those 4K sector disks, as we said. So you're thinking, okay, 64 terabytes per VM. you said over 250 virtual disks per VM. Now, I don't know about your maths. My maths isn't great, but off the top of my head, we're talking in the petabytes of storage per VM. That's huge. That's hugely scalable.
Now, let me jump in and ask a quick question. And, if we're going to cover this later, we could come back to this. But how exactly do we compare to VMware's VSA, the virtual storage appliance?
Good question. And I suppose I set myself up for that by having the virtual SAN question before. So I'll just keep digging my little hole here. So the VSA, for those who aren't familiar, maybe you haven't used it, even though you may be a VMware admin, the VSA can transform. If you imagine a small cluster, and it is restricted to 3 physical nodes, so 2 or 3 physical ESXi hosts, it would transform the local disks within each of those physical servers. So imagine you've got 3 physical servers stacked with SATA or SAS disks or whatever, and the VSA will aggregate that unused storage in those physical hosts, create one big volume per host, and then mirror it to another host. So if you think about host A's volume is mirrored to host B, host B's volume is mirrored to host C, and host C's volume is mirrored back to host A in a 3-node configuration. So it's transforming local storage into effectively 3 volumes that are appearing as shared storage. And the VSA appliance helps to orchestrate the control, the management of that. So Microsoft doesn't have a solution for that today. That's where we work with a number of our partners out there in the industry. Partners like Starwind, who will transform physical servers, physical disks within servers into a virtual SAN, different from the virtual SAN we were talking about with Fibre Channel earlier. Partners like HP, they've got solutions there that can transform local disk into a virtual storage appliance that you can then use for clustering. So in the box, we don't have that capabilities today. We will still require some form of shared storage. It could be a simple clustered file server that you could achieve relatively low in cost, but ultimately you would need that extra bit of infrastructure on top, unless you're using one of those partner solutions. So I urge you to check out on the web VSAs for Hyper-V. There's more than just the 2 vendors I've talked about there, but it's certainly worthwhile knowing. So great question. And hopefully I've dug myself out of that one. But leading on actually, and leading on nicely, whilst this isn't a VSA, VMware VSA compete, storage spaces helps me to transform disk within a server into something that's more resilient, just using commodity hardware. So I can transform disks, SSD, SAS, whatever they may be, into an aggregated pool of storage that I can then do some clever stuff with. And I want to give a quick demonstration of storage spaces here. So I'm going to pop back to my demo infrastructure. There we go. We're actually back in exactly the same virtual machine. I'm going to do this from a virtual machine perspective, so rather than a physical server perspective, but the process is the same. So what is a storage space? Well, a storage space, and I'm going to go to this pools option here in Server Manager. Storage space is going to effectively allow me to aggregate physical storage, or in this case virtual storage, into a pool of storage that I can then make available to other servers and services. So in this particular pool, I'm going to go New Storage Pool, and hopefully here we go, the New Storage Pool wizard. We'll go next, and all this can be configured by PowerShell as well. Everything in Windows Server 2012 and Hyper-V is PowerShell capable. So I'm going to choose Symon as my pool. I'm going to go next, and it's going to say, okay, which disk can you use for this? I'm just going to choose these 3 disks. In fact, I'm going to choose 2 for now. No, I'll choose 3. I'm so indecisive. Or am I? We'll go next. We'll go next, and we'll create. So all I've done there is created a storage pool. So I've aggregated those disks together and grouped them in such a way that now I'm presenting a complete view of the 3 disks together aggregated. How does this differ from physical RAID? Would I not do this in the physical RAID and as part of the BIOS and boot process within my physical server? Well, this gives you more granularity, certainly management whilst the OS is running. I can add and remove disks from the pool, and I can also do some cool stuff around trim and unmap capability that allows me to manage my storage effectively. So I'm going to go create a virtual disk when this wizard closes, because what we've done so far is just aggregated the disk into a pool. So now I need to create a virtual disk from a storage pool. So we'll go next, choose my storage pool, Symon, here it is, capacity 192 terabytes. Remember, it was 3 64 terabyte disks. I'll go next. I'll go Symon disk. We'll go next. Now, I have the choice of what this disk's resiliency will look like. Is it going to be striped across those 3 disks that I added to the pool? Is it going to be mirrored, or is it going to have parity? So I might get a little bit more capacity, but I'll increase my resiliency. I'm just going to go with parity. And the provisioning type for this virtual disk, thin or fixed. I'm going to go thin. What size do I want to make this? Well, we'll make it 10 terabytes for argument's sake. We'll go next, and we'll go create. So all we've done here so far is we've aggregated the physical disks within Windows Server into a pool. We've sliced a bit of that disk away to create a virtual disk that we can then configure a volume on that we can use for stuff. So that might be file share, it might be virtual machines, you name it. So here we go. Create the volume. Okay, which disk? I'm going to go, okay, that's fine. Volume size, the available capacity of this is 10 terabytes. I'm going to create a volume of 5 terabytes. Give it a letter. Okay, F drive is fine. We'll go next. New volume. Use Sybol. Sounds very technical and space age. We'll go next. Don't want to enable dedupe. We saw dedupe and what it can do earlier on. Pretty powerful, but I'll leave that off for now, and we'll go create. So it's formatting. So all we're doing there is literally we've gone from a Windows server that's got lots of physical disks, not RAIDed at the physical layer. We've aggregated them together into a storage space. We divided a chunk of that up into a virtual disk, and now we've formatted a volume on that virtual disk. And if I now go to the particular computer view, there's Sybol, 5 terabytes. And that's using those storage spaces. But like I say, I can do all sorts of cool stuff like enable deduplication on the storage space. I can use technologies like trim and unmap to ensure that capacity is optimally used. So when I delete big files, the storage subsystem understands that I've deleted them and will recover that storage as appropriate. So we're doing lots of cool things around that. And that was just a quick look at what storage pools and storage spaces can do. So I'm going to pop back to the slides. There we go. So to give you a bit more of storage spaces, how could we use storage spaces to provide a resilient infrastructure? Because what I showed there was carving up and aggregating disks within one server. If that server went down, no resiliency. So what can I do from a resiliency perspective? Well, I'm going to need some shared SAS or SATA disks, maybe in the form of a shared JBOD array. So something perhaps less complex than a dedicated SAN that's got 2 nodes for a resiliency and lots of disk shelves and so on. Maybe I'm just using a JBOD array, just a bunch of disks, just a JBOD disk shelf, and I'm using perhaps some special RAID cards that allow me to provide clustered storage just through these special RAID cards that are now available on the market. So imagine 2 physical servers connected to a JBOD array, so a simple disk array, but using those RAID cards to share access to that, which can transform it into a piece of shared storage. But I can aggregate those physical storage into the pools, as we saw. So remember, I'm transforming JBOD into effectively virtualized storage in Windows. I can extend it as necessary as I see fit, so I can add more disks to that and extend and then grow my storage space. And then from there, all of these other things within Windows Server understand storage spaces. So SMB, storage management, cluster shared volumes, clustering in general, they're all storage space aware. So it's a very integrated solution. And then on top of that, I can start to use those storage spaces for running VMs or SQL databases or however I see fit. It's just effectively transforming commodity storage to give you a resilient, easy to manage, flexible storage platform for your next generation of workloads. So a couple more. ODX. Now ODX for me is one of the most exciting areas of Hyper-V from a performance perspective. Because what ODX enables me to do is say, okay, Mr. SAN that we've invested in with SAN vendor X, what I want to do is say, okay, this task I'm going to perform, which might be a storage migration of a VM, or it might be a creation of a new virtual hard disk for a VM that's quite big in size. Instead of me, the host, doing all of that and using my valuable resources like processor and memory and network, I'm effectively going to be doing stuff with blocks on the SAN. Maybe it's a clone. A migration would obviously be just moving stuff around the SAN. Can you, Mr. SAN, do that for me? If that's the case, then that's great, because that's going to improve performance all around. Things are going to happen quick on the SAN, and I'm not going to be burdened with kind of stuff on my host. So to explain that a bit more, ODX effectively says, OK, what we want to do is, firstly, I want to say, okay, I'd like to do some kind of copy. I'm going to do a copy request of some files, and they're ultimately moving between two places on the storage array. So the actual data isn't going via the host anywhere. It's not using that valuable resource. We're just sending a token that's come from the array. So this needs to be an ODX supported array, of which many of our storage partners are now bringing to market updated firmware or new arrays to provide that support. That token that comes back from the array effectively contains all the information about what we're trying to do. So we're trying to move all of that data from A to B, and we simply transfer that token to the target, and it all happens. So the data is just moved on the SAN, okay, and we write that back to the server that's in question to let it know that that particular task is completed. So there's lots of benefits we can take. So rapid provisioning of virtual hard disks, faster transfer on big files, less CPU and network use. Performance isn't limited by the network that's available. We're just saying, okay, SAN, you offload, you handle all of that stuff for us, which makes it more effective and all-rounder and more efficient process. Now, my storage array unfortunately doesn't support ODX. I haven't got the updated firmware for that just yet.
Now, there's a few questions coming in about ODX. You know, can you use this with a cluster?
Can you use it with a cluster? Great question. Absolutely.
Can you use it with cluster shared volumes?
Absolutely.
Can you use it with SSD disks?
SSD disk in the storage?
In the storage, yep.
I don't think it would make a difference. I think the SAN vendor, just as long as they support ODX, the disks in the SAN doesn't really make a difference. Stuff would happen really quick. I mean, it would be great. Yeah.
Great, thanks.
No worries. So just a bit more in terms of ODX support. What kind of things can we do? Well, creation of VMs, rapid. Think about creating a 10 terabyte virtual disk. That is going to fly on an ODX SAN. It may take a little bit longer when you're using the host resources and there's a copy and write process going on there. Dynamic virtual disk expansion, again, flexible, quicker, less performance impact. Merging virtual disks after a snapshot, which I'll add is now online, so you don't need to shut down VMs to merge snapshots. And then we think about storage migration, moving virtual disks around from one LUN on the SAN to another. Again, that kind of stuff is enhanced with ODX. And just one example, creation of a 10 gig disk, fixed disk. So we're zeroing out all of the blocks in that particular disk. 3 minutes on an average desktop without using ODX, less than a second with an ODX capable array. So you can see the impact that it would have, huge. And this is very similar to the VAAI, the vStorage or API for array integration that exists in the vSphere world. So if you're used to using that capability in there, you would also be able to benefit from that kind of thing from a Hyper-V perspective as well. But it's important to note that you don't have to do anything. If the SAN supports it and Hyper-V obviously supports it and it will recognize that the SAN supports it, you're good to go. It will just harness it and take advantage. It's not a big tick that you have to turn on. And the final one, we're thinking about booting from USB disk. So a USB stick inside the particular host that you're running Hyper-V on. Hyper-V server can be installed to a USB disk. Windows Server 2012 Hyper-V, no, just Hyper-V server. So that gives you a new deployment angle, a new option if you want to look towards a diskless server. And there's loads of information on TechNet about how you achieve that. So when we start to look at comparing with VMware, both the vSphere hypervisor, so pure ESXi, and Enterprise Plus, that top-end SKU. When we think about virtual fiber channel, it's in the box on all three, which is great for organizations who are looking to harness that for perhaps guest clustering, which we'll talk about more later on, or just passing through virtual fiber channel storage through to a VM. We talked about multipathing, MPIO. Being able to use multipathing inside the VM as well as on the host, great. I can use the core multipathing framework that's in Windows Server. But if you want to use the HP, in my case, DSM, device-specific module, to optimize that in relation to my HP storage, then I can do that with Hyper-V, but in VMware, I have to be using some of those higher additions to use what's known as the vStorage API for multipathing. so to use those third-party device-specific optimizations. We support 4K disks and bigger virtual disks than compared with VMware. Offloaded data transfer is in some of those higher-end SKUs on the vSphere side. It's in every edition of Hyper-V. And all three platforms support boot from USB. But just remember, it's Hyper-V server only. Okay, that's important. And finally, that pooling. In core vSphere, without that virtual appliance, the vStorage appliance, you're going to be lacking some of the pooling, but storage space is obviously included in the box within Windows Server 2012 and Hyper-V Server 2012.
Great. Well, let's move on to talk a little more about resource management. First, I think it's important for us to really define exactly what we mean by resources, because there's so many things out there. Essentially, with resources, we mean your virtualization resources. More specifically, your memory. How do we take care of that? How do we allocate it? How do we use it as efficiently as possible? Now, one of the questions that I've seen come in a few times is asking, do we have the ability to hot add memory, to basically dynamically assign the maximum amount of memory that can be allocated to a virtual machine? Matt, why don't you take that one?
Yeah, I can take that, and I can also show you it if you want.
Hey, let's do that.
There you
Even
go.
better,
I
right?
can show you hot add as you use it. Yeah, I like that. So dynamic memory, to give you an idea of what it's all about, dynamic memory is helping organizations to increase density by better utilizing memory as available, because some VMs will be quiet some of the time and some VMs will be busy at different times. So if you've got a quiet VM, a file server for instance, that's quiet overnight, and yet you've given it 8 gig of RAM, and yet it's sat, the memory demand inside that VM is a gig overnight, you've wasted 7 gig of your physical host that we could be using for other things. So dynamic memory will allow us to allocate memory in different ways optimally to the guest OS. So let's dive into my environment. In fact, let's move out of that one and move to this particular one here. So I'm in one of my environments now in Hyper-V Manager. This particular Con Demo 01 has dynamic memory enabled. Okay, so it's a feature that I've turned on. If we look at the memory tab here, dynamic memory enabled, minimum memory 512, maximum memory is 4 gigabytes. Okay, so Simon was saying, how can we hot add? Okay, what is the option to hot add memory to a running machine? Well, let's firstly look inside the VM at the settings. And you'll see this memory here, this memory option, and you'll see this VM has a couple of different options that I can configure. The first one that's grayed out because the VM is running is the startup RAM. What is startup RAM? Well, if you think when you boot a VM, or a server in general, when it's just starting up and it's got a particular function, maybe it's running a database or it's a web server, or something, it needs to get itself sorted. It needs to get itself to a point where it can then calm down. The startup memory is basically saying, okay, you can have at startup 512 meg in this case, or it could be a gig or 10 gig or whatever. That's what you're going to have to start up. So the VM will get that, it will have enough memory to do what it needs to do without it needing to page out to disk, which is slower, and so on. But from that point forward, we can then utilize these dynamic memory settings to say, okay, your startup was, say, 10 gig, but once you've settled down, we know that your minimum memory could be a gig. So I could have minimum memory a gig in here, which would mean, okay, once you've settled down, you would drop to a minimum, almost like in the VMware world, it would be a reservation, if you will. That's the minimum we will give you. Okay, that's the minimum. But the maximum is the limit. That's the top end of what we'll give you. So your startup could be, let's say for argument's sake, to make it simpler, 3 gigabytes. The VM starts with 3. It settles down. It's not doing anything just after it started up. It settles down and gets down to 512. But then somebody logs into it, starts using an application, it rises, and it will never go higher than 4096 or 4 gig in this case. Where the hot add comes in is I can change these figures on the fly. So if my VM is starved of RAM, it's literally, we're running an application in there, maybe it's a database, maybe it's an email system, and we're looking in Hyper-V Manager here, and we're seeing memory status listed okay. But if we're struggling here, if memory demand is outweighing what we've assigned to it, there's going to be listed as a warning here. It's unhealthy. The VM is struggling. It can't handle it, and we're swapping out to disk inside the VM. We're paging out. That's bad performance all round. We've not modeled that workload appropriately. So with memory status being warning, we could go into the settings of that VM. We could change it from 4096 to, I don't know, 8124. That's 8 gig, isn't it?
Yep.
And go apply. And from that point forward, the VM will grow into that RAM. So we're not saying here just add an extra 2 gig chunk. We're just saying, okay, we'll just increase your maximum. We're not changing the minimum in this case, so if the VM does calm down again, it's going to go back down to that minimum level. Okay, so that's how we hot add. Hopefully that kind of answered the question and showed you a bit about dynamic memory. But dynamic memory is helping us to enhance and deliver a more optimized and resource optimized usage of that physical hardware. Because ultimately we're able to manage memory between VMs and achieve a better level of density. But I want to talk briefly, now that we're back in the slides, about how that compares and contrasts with VMware. Because there's going to be VMware admins in the room watching virtually at home who are going to be thinking, okay, well, VMware has a couple of different techniques for memory management. Memory over commit, the ballooning, which probably is closest to dynamic memory if you were looking at them apples to apples, where you're inflating a balloon inside the virtual machine, not literally, to push out memory that's not needed at that time and reclaim it and use it elsewhere. That's similar to how dynamic memory works, at least at a high level. But there's a couple of other techniques that VMware have, like transparent page sharing. It's one that gets brought up a lot. TPS, deduplication of memory pages. So you've got lots of VMs that are doing pretty much the same thing. The OS is similar, perhaps. And we can look across all of those VMs and see where the memory pages match and deduplicate them, freeing up spare memory to use for other stuff. But with regards to that transparent page sharing, what it gives us from a VMware perspective, yes, it can free up that spare memory, but more and more hardware now, and I'm sure you've seen this in recent times as well, and more hardware has got large page tables enabled for performance. Large page tables are harder to match and deduplicate and require more work from an ESXi host perspective to deduplicate. So you think about a 4K set of pages and page tables versus 2 meg, matching 4K versus 2 meg, it's a different ball game. So really, when the host is under extreme memory pressure, yeah, it's going to kick in. It's going to start to try and deduplicate, break down those 2 meg pages into 4K, and then deduplicate. But it's already starved of resources at that point. So it's a kind of a bit of a last ditch. Microsoft doesn't have that transparent page sharing approach. We don't believe it's optimal. We think that large page tables is enhancing performance, and with dynamic memory, we can offer a great option as well. And there's also swapping and compression within the VMware infrastructure. Compressing memory inside the VM, a certain segment of the VM to free up memory, but not all pages can be compressed. And again, it's a kind of last ditch when memory is kind of heavily overcommitted. And swapping out to disk. People talk about using SSD in hosts for that swap file location. But even with the best SSDs in the world, you're never going to match the performance, at least today, of RAM. So there's still going to be a performance hit. So it's something to be aware of. With dynamic memory, we've kind of talked about it now already. Improvements in Hyper-V, we can set that minimum, we can set that maximum. We're ballooning inside the virtual machine, and it's allowing us to say, okay, if we're using this much memory, it will grow over time, and we can set it up to that maximum. And we can increase the maximum memory without that restart, so we're able to do that hot add. But we've made improvements that are leading to higher consolidation ratios, improved reliability, because we're able to manage the memory more efficiently. And with that increase in memory, that hot add, if we want to call it that, it's allowing us to be more flexible.
Now, I've seen a few questions come in basically asking, does this work inside Hyper-V? Does this work inside Hyper-V? Does this work? So I just want to kind of address all of those really quickly. Microsoft's goal is to make every single Microsoft product be a first-class citizen of Hyper-V. So with some of our previous releases, you might hear an older version of SQL may have some issues. But right now, all the Microsoft products have been designed with what we call the common engineering criteria. Really long checklist of all types of requirements that every engineering team needs to complete for a product to ship. And one of these is full support of virtualization, including all of the features of virtualization, such as live migration, dynamic memory. So you can be assured that all of the new Microsoft products that come out with this wave, fully tested, fully supported with Windows Server 2012, and all of the different Hyper-V features. And I'm going to quickly post a link here in the chat to KB article 957006. I've referenced that one a lot. And that has a complete list of all the different Microsoft technologies that are supported within the guest operating system. And it's constantly updated. So as we continue to ship new products, you'll see these all listed here.
Wow, your memory.
The 957006.
Yep.
So keep it
I don't know if that's a good thing or not. You can also go to www.windowsservercatalog.com and have a look on there. There's links to the supported software and stuff inside the virtual environment as well, if you didn't remember the KV article off the top of your head. So I want to go back to some of the other resources. So memory is a good one, and hopefully we've talked a little bit about dynamic memory, and if there are questions coming later, we can talk more. And we feel we've got a very strong solution that allows customers to achieve great levels of density with Hyper-V. But there's other kinds of resources. What about how can we measure stuff? How can we track historical data? As an IT pro, if you said to me, okay, I want you to tell me everything that's going on all your virtual machines and your hosts, and all you can use is perfmon, I think there would be tears in my eyes. Because as good as perfmon is, it's going to be a lot of manual administration to collect all of those relevant metrics and present that information in a way that's meaningful to the business. Resource metering in Hyper-V is the start of what we're delivering as a foundation to be able to collect all of that metrics and information in a meaningful way. And we'll see our System Center later on in the day extends and enhances that with dashboards and rich views and stuff like that. But I want to give a quick demo of resource metering. So I'll move over to my Hyper-V environment. And I've got, as all good IT admins would have, a notepad file on my desk here, on my desktop even. And what it's got here is 3 PowerShell commands. Now, the first 2 I've already run, but I wanted to explain them to you to ensure that you knew what I was doing and how I got to that point. So let me just open PowerShell while it's there. So the first one is enabling VM resource metering. So you see, I was using my extensive PowerShell skills to say, get VM computer name, the host name, there it is, and enable VM resource metering. That is a mind-blowing PowerShell script. Set VM host, computer name, yeah, okay, a few more bits. The interval to collect metric data every 30 seconds. You can be granular about how you do that. And then finally, the one that I want to do, I want to run now, I'll do a copy and a paste. And hopefully, this will go away. Oh no, that's not going. Let me see if I... Let me try again. This is what I would run, and what I would see, normally, please, are the demo gods with us. There you go, yeah. Gods. So, an important point when administrating and using PowerShell, right-click, run as administrator. That was a quick demo of what would happen if you hadn't run it as administrator. Just want to clarify, there was reason behind that. Method to the madness, I call it. This time, running it as administrator, you see a completely different view, much more useful to us to see what's going on our VMs on this particular host. And remember, I use computer name specific to one host, so I could run this in more detail. And this is giving me information that I could pipe out to some XML or other document format, or System Center will collect all this information, and we'll see this later on. But you're seeing that over the period of time, average CPU, average memory, maximum, minimum, total disk usage, network that's been in and out. So I can be pretty granular, and this is just one view that I've used with my relatively limited PowerShell capabilities. But it's easy. It's easy to get going and understand it, and there's loads more on TechNet. So if you're interested in capturing this, particularly if you're thinking about delivering something along the lines of IT as a service within your environment, within your enterprise, you might want to start charging HR. They've got some applications and services running on your system. You're managing it. What do you ever see from it? Well, maybe now it's time to start charging. But this allows you to at least start capturing what they're using. If Symon was borrowing my kit, I could say, well, you've got 3 VMs, you're using a lot of resource, can I have $1,000 please, or whatever. I'm not going to do that to you because I'm not nasty like that. But that's a little bit about resource metering, and it's enabling me to capture a lot of those metrics and useful pieces of information across my hosts or resource pools that I can define in Hyper-V. And I can not only capture things at the virtual machine level, but I can also start to meter what's coming in and out from an internet perspective, different from the local network traffic that's going on the intranet as well. So I can be pretty granular, and it's enabling me to capture all that information, so I can see VM as the animation is animating in a very lovely way. Different VMs are using different resources, and I can perhaps build them accordingly if I build a chargeback model around that.
Now, I have a question come in here. A lot of people have traditionally used System Center Operations Manager to monitor VM usage, capacity, things like that. How does this exactly fit in with resource metering? Can we take advantage of this through OpsMan? Could you use one or the other?
Good question. I think the key thing is if you're looking to build chargeback models through tools like System Center Service Manager. That's going to tie into resource metering specifically. But like you say, Ops Manager was a good way for organizations to capture a lot of metrics about virtual machines, about physical systems, storage, network, and so on. This is given it in a VM-specific way that is aggregated and used and could be visible in Ops Manager as well, but if you're looking to build those show and or chargeback models, which again we'll talk about later within Service Manager, then that's going to be a way to do it. So I think all the information is just how you present it in a different way. Ops Manager would grab some of it, Service Manager would be able to present it in such a way.
Great, thank you.
So, as I said before, we can also meter and manage and collect information about what's coming in and out from an internet perspective. So you may have a customer you may be hosting their infrastructure and stuff may be coming in through the internet and you want to meter that. Maybe you're charged for your bandwidth usage. You want to pass that on to the customer or internal business unit. That's up to you. So a couple of other areas. Quality of service. How can I provide, so I'm hosting Symon's infrastructure. According to him, it's mission critical. I'm not so sure. I'm hosting Symon's infrastructure, and he said, you know what, can you guarantee me level of service for my stuff? Because if you can't, I might look elsewhere at a different hosting service provider, or I might go outside of IT. What do we mean by guaranteeing a quality level of service? Well, I want to ensure, and I'm going to go into a demo in a sec that shows this again, I want to ensure that I can give a consistent level of performance for key workloads that are running on my platform. So I want to be able to say, okay, I'm going to guarantee that even in contention, when there's lots of virtualized workloads on here, that your workload, Symon in this case, always gets this minimum. But I'm also going to stop you from being noisy, because if your VM suddenly spikes up and starts doing loads of stuff and consuming lots of bandwidth, my other customers are going to start to suffer on my other VMs or workloads. So quality of service is going to allow me to sort that out. So we'll go into a little bit of a demonstration and have a quick look at QoS. So let me bring up, so here we go. In fact, let me just change my VM. So many VMs, so many demos. So minimize here, and there we go. So what I'm going to do is I'm going to run a little server app here. It's very complex. It's basically just going to send traffic. That's all it's going to do. It's going to send stuff across the network to a certain VM that's going to have the client receiver at the end. So I'm going to go from there. I'm going to minimize. I'm going to go back to my other machine, and then we're on the client side. There you go, it's connected, it's going to send, it's sending data for a 5-second interval, bang, there we go. It sent 350 meg at a rate of 583 meg between these two machines. Now, that's great, but that's noisy. That's using a lot of resource. That could be affecting other VMs. You know, Symon's customers who are visiting his website, they might be struggling at this point because of what I'm testing here. So I'm going to go to the file, settings of this particular VM, Symon's important VM. I'm going to say, whoa, enable bandwidth management, maximum 50. I could say minimum if I want to guarantee an SLA. I'm going to say maximum because I'm a bit tight. So I'll go enable bandwidth management, 50, there we go. The reason I'm doing it on both network adapters is because there's two in this VM and they're both attached to the same network. So if I only do it for one and the test uses the other, there'll be no change. So I'm doing it for both. So we'll go apply, and you'll see now bandwidth management has been enabled. We'll go OK, we'll run it again.
Now, would hosters be able to take advantage of this feature?
Yep, exactly. Hosters, service providers, large enterprises, small enterprises. Even if you want to just say, you know what, I've got a selection of VMs on a few hosts, and I want to ensure that they all get what they need. Effectively, there's a minimum. I might not use maximum, I may use both. I use specific numbers there. I use 50 meg as the number, but I could use weights as well. So as you know, one is weighted 5, another 3, another 1. The one that's 5 is going to have the most resource if there's contention. So there you see, I've restricted it to 50. Same process, but I've just changed I've controlled through quality of service there and bandwidth management. Now in the VMware world, and just going back to the slides, there are other options for quality of service. So I showed network there that's native to Hyper-V, but there's also options around storage QoS in the VMware world, or storage I/O control as it's known. And Hyper-V doesn't have that in the box. But Hyper-V, in conjunction with some of our storage vendor technologies, HBA vendors and so on, can provide those granular levels of I/O control if you're looking for them. But in the box, we provide that network QoS, which is, you've seen how easy it is to configure. Could have done it through PowerShell as well. So we've kind of talked about this already, a minimum bandwidth, a maximum bandwidth, and ensuring that fair share. And I can exceed my quota, assuming there's no congestion, but I'm just trying to control and provide more granularity around how I deliver bandwidth. But I can do it in software, but I can also do it within hardware. So if I've got a network adapter, and it refers to it at the bottom left of the slide there, so two mechanisms. Enhanced Packet Scheduler in software, that's what we just showed. Network adapter with DCB, Data Center Bridging Support. So we're saying, okay, instead of me doing it in software like I just showed, let's use the physical hardware. Let's use our converged network adapters. So storage vendors, network vendors, in particular network vendors who are bringing to market converged network adapters that converge all of this traffic, storage traffic, networking, all of that stuff, and manage it through tools within that hardware. We can take advantage of that, and we can offload that QoS to provide perhaps a little bit more granularity as well. So you've got two options. If you've got converged network adapters, great, we'll take advantage. If not, you can still do it in software. So to wrap up and look at the VMware comparison for this section, we've looked at a lot of resources there. It's a slightly longer section than part one. Dynamic memory, memory management, efficient memory management is in all three versions that we're looking at here. The free Hyper-V server and Windows Server Hyper-V. It's in the free vSphere hypervisor, and it's in Enterprise Plus and all of the other SKUs. It's core to VMware's offering. And all three solutions allow you to enhance the density versus not using it. Resource metering, we saw it was in Hyper-V. We saw a quick demo of that. It's in all the editions of vSphere as well. But if you want to aggregate that from a Hyper-V perspective, you're more likely to be using System Center. Same with vSphere. You're more likely to be aggregating all of that information into vSphere and vCenter specifically. We showed QoS. It's not in some of the lower SKUs. In fact, it's only in the Enterprise Plus edition. So network I/O control and storage I/O control.
Now, we had a question here, just wrapping it up about dynamic memory. Now, once you've adjusted the minimum and maximum of the dynamic memory, does that mean that maximum is only allocated to that one VM? So, for example, if I assign a maximum of 1 terabyte of memory to a particular VM, can other VMs be able to use any of that memory? Yeah,
you can. Yeah. So you could realistically say, okay. In fact, I think when you create a VM, I can't oversubscribe beyond what's in my physical server. So I can create a VM on Hyper-V, new VM, use dynamic memory, yes, and it's going to use the maximum available on that server. So if you've got 64 gig can be the max there, 128 and so on. But I could give each of my VMs a maximum of 128 and just let Hyper-V manage it.
Okay,
so
great.
You can do that. So it's not kind of saying, okay, if VM A, I've set a maximum of 64, and then on a 128 gig host, the remaining VMs can only share the remaining 64. It's not like that. It's more of, I can give a VM 64, I can give another VM a max of 64, but if they both need 64, and we've only got 64, they're not going to both get 64. It's going to share it appropriately. And you're probably going to get a warning in Hyper-V Manager to say, demand, assigned, they're not.
We have a problem. Yeah, okay.
Houston, we have a problem. Yeah, exactly.
Now, the second question we have is about resource monitoring here. Is resource monitoring live? Meaning, can you get live statistics about the utilization of those virtual machines?
Good question. Is it live? I mean, it's capturing it historically. It's capturing it over in my example, every 30 seconds it's aggregating, it's providing some of the average stuff. So
it's live up to 30 seconds, essentially?
Well, it is essentially, but it'll have captured the 30 seconds previous run and added it and averaged it out. So what you're looking at is perhaps more of a historical chart view but Service Manager would allow us to start to map those and help us accurately capacity plan. But I don't think it's live, what we are broadcasting live resource metering this minute. It's probably more delayed and aggregated together. But that's something we can investigate and look at as well.
Great. Well, thanks so much, Matt. As a reminder, there are polls which are now open. So if you're in full screen mode while viewing this, please minimize that, answer our poll so we can learn a little more about you. And don't forget, we have some excellent Q&A happening, live Q&A with myself and our team of experts. Right now we have Namish, Avery, Tiberio, Rick, Brian, and Adam helping out with Q&A. So please type in all your questions. Let us know what you want to know about Microsoft virtualization. With that, we're going to take a short break, and then we'll be back. Thank you.